Our third speaker is Ellen Baum. She is a senior scientist with the Clean Air Task Force, which is a nonprofit organization dedicated to reducing atmospheric pollution through research, advocacy, and private sector collaboration. In recent years, her work has focused on the linkages of air pollution and climate, with a special emphasis on the scientific and national and international policy issues of short-lived climate forcers, including black carbon, ozone, and methane.
Okay, well, I want to make sure I know how to use this, right? I want to thank EPA for inviting me. I want to tell you all how terribly humbled I am to be here, since about half the people in this room have taught me everything I know about black carbon. And some of you will recognize slides that I have here, and if I have misused them, it is entirely my fault. I am keeping my entire presentation here, but I will be passing very quickly over a number of slides where I know that other people will be talking about it later on in the day, and that's just so that the talk itself has some integrity, if anyone ever looks at it in isolation. So I'm being asked to talk about what some of the international and domestic policies are for black carbon, and the answer is there are none. It's possible that one could interpret some of the California laws that would speak to an actual black carbon regulation. What we do have are programs for primary and secondary particles, total suspended particles, PM10, PM2.5, and these regulations are driven by health and ecological concerns, and there may or may not be climate benefits from those programs. And as we'll be talking about today, the role of black carbon that will contribute toward climate, there's lots of factors that are going to be influencing whether or not black carbon and particulates are warming or cooling. So I'm going to talk about the outline for my talk today is just looking at some of the sources of black carbon, what is being done, what could be done, and then I'm going to make sure I have a word about tropospheric ozone as well, which is a topic dear to my heart too. This is the first slide I may be misusing, but this is now a very common slide that Tammy put together for an Arctic meeting that we were at, and we were trying to figure out what were the sources of black carbon by latitude and which ones might have the greatest impact in and near the Arctic. And this has gotten quite a life of its own, and I think we'll see it more. But you see that the major sources are the same ones that were on my first pictures and that I said I would be talking about. This is something I'm going to pass through really fast. We understand that diesel and transport is a major source of black carbon, particularly in some of the developed countries. Well, no, particularly worldwide. Let me take that back. And we also know that it takes low sulfur fuel in order to use these diesel particulate traps. So some of the options for some of the higher emitting vehicles of diesel are either to get low sulfur fuel so you can install a diesel particulate filter, or in other parts of the world we have scrappage programs. That's all I'm saying about diesel. Everything else you'll hear later on today or tomorrow. That moves us to marine vessels as another source. They're actually a fairly small source, estimated to be about 2% of the global black carbon, but the greatest concern is their release in some of the northern shipping routes close to the Arctic. And there are some estimates that are projecting that with a warming Arctic, shipping will increase by 2 to 3 times the global rate between now and the year 2050. The air emissions from ships traveling in international waters are subject to regulations by the International Maritime Organization. And on January 15th of this year, Norway, Sweden, and the US filed a joint paper to the Marine Protection Committee of the IMO requesting that the committee discuss how to address black carbon by including potential measures recommended or required to significantly reduce black carbon emissions from shipping having an impact in the Arctic. And that will be heard and begin to be discussed at the next IMO meeting. In that petition, a few measures were presented that would be able to reduce black carbon from ships, and these include improved fuel injection systems and modified turbochargers, diesel particulate filters, water mixing and injection technologies, and slide valves. Another area of black carbon emissions that may in particularly be influencing the Arctic and other snow-covered surfaces. So this would not be limited to just the Arctic, although this exercise that I'm showing you here was designed just to begin to look at what we might have for fire burns that are reaching the Arctic. This is looking at north of 40 over the 3 months of spring burning. With the idea that those are the fires that we already know that fires from that latitude have been reaching, at least in the atmosphere, reaching the Arctic, and some of the deposition data suggests biomass deposition in the Arctic as well. We took that and came up with very crude black carbon emissions estimates from that, and this project did exactly what I wanted to do. We knew it was crude, and as soon as people saw it, this was in a report we put out, people are now redoing these numbers because they want to get them closer to right, and that's just great as far as I'm concerned. And we're working right now with some Russians and someone from Just McCarthy at University of Louisville to try to improve what we get for BC emissions from fires. In terms of what some of the options are to reduce fires, the agricultural fires that might be affecting the snow and ice surfaces. There are bans that can be in place. We can expand use of crop waste, biochar. It can be produced via pyrolysis, and the char can get put back into the ground, but the pyrolysis unit can have the emissions better controlled. And then there can be timing and permitting of fires based on meteorological conditions and forecasts to avoid transport to the Arctic and to other vulnerable areas. Burning controls, burning is regulated in the U.S. at the state level, and requirements vary by state. Many states require permits for open field burning, and state officials post no burn periods during dry or very high wind conditions. Some upper Midwest states ban burning entirely, although we can see from fire burn data, both from MODIS data and from burned area data, that actually field burning is occurring. Burning has been banned in most countries in Europe, but again, there's evidence that those bans are not always enforced. And then elsewhere in the world, there's real variety in terms of levels of restrictions and enforcements. Household fuels, this is something else I'm actually not talking about today because we'll be hearing about from so many other people. But there's just two things I want to say about household fuels. One is that this is more than just a lower latitude issue, even though that's largely where the household fuel issue will arise. Scandinavian countries, their major source of black carbon is likely coming from sauna stoves in Finland and other cook stoves that are commonly used in Scandinavia. The other thing I want to make sure, the other point I want to make sure is when we look at improved stoves, we want to make sure that we understand what the emissions actually are from the improved stoves to know that we're getting black carbon emissions at the same rate that we're getting emissions in other particulates, since we know that is really where the climate benefit is impacted. Okay, this is an area that we're increasingly interested in. Industrial sources are estimated to produce a significant fraction, maybe 18% of global black carbon emissions. Major fractions are uncertain, but in order of contribution, it looks like it's mostly brick kilns, coke making, and other boilers, pottery, bread, ceramic kilns, lime kilns. Emissions information for most of these sources are very limited, and they're based on very, very few measurements. This is brick kilns. We have about 300,000 of them are located worldwide. In China, they're dominated in China, followed by India, Pakistan, and Bangladesh. And then there's many places in Asia that have pretty significant numbers of brick kilns as well. There are shifts to improve technology kilns, and they will reduce fuel consumption and carbon dioxide emissions. And black carbon emissions controls will likely occur by replacing kilns with improved technologies, but and this is going to sound like a mantra for me, but we really need the measurement of climate-relevant emissions to quantify what the opportunities are from improving brick kilns. If there's anybody out there, I've got a great proposal with somebody in India and people in Thailand who are interested, capable, ready, and to do some of those measurements. In terms of controls, the low fuel efficiency, high polluting continuous kilns have been banned by law in China since at least the mid-90s because of their very low fuel efficiency. Some highly polluting kiln designs, while widely used in South Asia, have been banned in India since 2002 and in Nepal and Kathmandu Valley since 2004. In January 2009, the Environmental Protection Agency of Pakistan ordered that brick makers in and around the capital close their operation or switch to alternative technologies because of the high level of pollution produced by primitive kilns. I have no idea what the enforcement is on any of these or the success of any of these orders. All right, coke making. There are a relatively small number of coke-making facilities worldwide, maybe about 1,500. It is dominated by China, followed by Russia, Ukraine, US, and India. And China, most of the growth is growing in China. In fact, 96% of the global production growth since 2000 has happened in China. And it looked like there was a little bit of a downturn in the last couple of years, but that's gone right back up again in this past year. I am missing a slide, and I sent you a missing slide. And what that slide is what we've seen for some of the controls already on coke making, and what some of the options are. For primitive and modern kilns, there really is an opportunity to move from the more primitive to more modern kilns and to install measures at different high-emitting points in the coking process during the operation and processing, and also to have better maintenance. And that should yield reductions in PM. Well, it will yield reductions in PM, and presumably it will also yield reductions in black carbon, measurements that we would like to make to confirm that that is the case. Also, what modern coke ovens have is a combustion stack, and so that will allow for installation of pollution control equipment. We also know that China is phasing out their primitive coal ovens, and that does seem to be occurring. Flaring from oil and gas. Oil and gas look at how black that is. So we sure think that there's some black carbon there, but there's, again, been very few measurements, and, like diesel engines, there's not, one flare does not mean all flares, but we really don't even have emission measurements that are very good for one flare. So we have a lot of questions about this. We need to be developing protocols to quantify PM from these sources, and then for a control mechanism, we need to see the extent to which we can get methane capture from these flaring operations. And where that's not occurring, there are market constraints, transmission constraints, and other constraints. We need to figure out what those are so we can deal with those. All right, I'm going to talk about ozone. Ozone abatement strategies have really evolved over the last 50 years, from it being an urban problem that we thought was VOC limited to a regional problem where it was much more NOx limited, to what we have, what I'm calling today is much more of a global perspective, where we're also looking at the climate impacts, the role of intercontinental transport, and the background, because that background level ends up being critical for climate, and it's also critical as we're trying to set what the standard should be for health concerns. We are seeing the background level there's an upward trend in background ozone, and we want to figure out ways that we can be lowering that, because that is so important for climate. EPA has recognized this in their July 2007 staff paper in which they say that the welfare impact of ozone on local, regional, and global climates has received more attention in recent years. Ozone enhances the heat capacity of the atmosphere. The overall body of scientific evidence suggests that high concentrations of ozone on a regional scale could have discernible influence on climate, leading to surface temperature and hydrological changes. However, confirming this will require further advances in monitoring and improvement in chemical transport and regional scale modeling. So I think that falls on EPA as an onus to be doing that, and hopefully they will. We look to methane reductions as one of the opportunities for background control of ozone. And I'm just going to conclude really with where I started. We don't have black carbon regulations. They are controlled by PM regulations. Some sources offer some very large climate benefits. We need measurements, and we need to focus on strategies to reduce background tropospheric ozone. Thank you.